Anyway, so welcome to YAPC. And I've done the talks on closures for the last few years. How many people here play with closures on a regular basis, just as part of your programming? Okay, has anyone here used any of the new OO Perl internals? Then you use closures too. The whole object method, the object closes over the class. That's how they made it work. Anyway, so welcome to YAPC. And yeah, like I said, people use them even without realizing it. And the great thing about them is just how simple they are to construct. And closures in Perl look like closures in Python and Lisp and any language that supports them in C. What I'm going to do today is go back over, for any people that haven't suffered through this twice before, we'll get a quick introduction to what closures are and why they make sense. And then I'll look at an example from Perl 5, mostly using L values, and then look also at Raku. So the whole point of a closure is you've got a subroutine that keeps a lexical variable alive in its scope that otherwise goes out of scope in the rest of the program. So a classic thing, people make a mistake. You don't have to have an anonymous sub to make a working closure. All that has to happen is that if the lexical variable is visible inside the scope, it's not visible outside of that scope. So the subroutine or the do block or whatever keeps that value alive where it isn't visible elsewhere. So classic example, really simple closure. I have verbose on here, and if I set it to env of verbose, classic problem people have is they check $env of verbose every time they go through printing. And your debug is supposed to be silent, and halfway through a program, you fill up the disk with debug output. The problem is that env of verbose is a global, and some third-party class over there can switch it on by mistake. And because you're sharing a global object, you're going to start spewing out debug output. The trick here is my $verbose, once I've assigned it at almost a compile time, I don't care if env of verbose changes. So now my debug is safe from changes in that global variable because it's using a private variable that isn't accessible elsewhere. If you look in that info sub, if you're in the Perl debugger and you try and say what's verbose, you're going to get undef. The variable literally does not exist in info. It's not that it's not visible, it's not accessible, it's meaningless. So that debug is a closure on verbose. You can do the same thing too with blocks. A lot of people use do blocks or naked blocks. You can have something like this where I set verbose, and these were pretty common for a long time, and then Perl picked up state variables. People use state variables? I'm not getting a lot of hands. A lot of more people should be using state variables. They're great. The state variable is basically the same as this. I've got a variable that is scoped locally, but whose value is persistent between calls to the subroutine. And this is taken straight out of C, state variables in C. So what this says is the state variable is assigned the first time I pass through the block, which can drive you crazy if different classes change this global variable at different times. You can have order of execution bugs. But once you've assigned verbose, the first time you enter this debug, you've got a private value that won't change again. No one else can see it. Is this making sense to people? Everyone with a heartbeat, raise your hand. Okay, I haven't killed you yet. I'm smart enough not to ask if anyone's awake. So closures can be anonymous. And one of the most common places you see them is they're created in loops or in factory subs. Let's say I want to generate a debug. One of the really annoying things is if all of your debugging goes through one subroutine, you might want to put a prefix. This came from this part of the code, or just a standard little header, so that you can tell where the debug output is, what it's associated with for troubleshooting. So here what I can say is I'm going to generate a subroutine that's going to give your prefix plus your arguments, or give me a nastygram that you're supposed to tell me what to debug. But you always see the prefix. Now, different parts of your code can say my debug output says file reader, and my debug output always has a leading, game move or monster or person or thing. But now when you're troubleshooting this stuff, you can grep out the prefix and see what one particular thing was seeing, or you can sort them to see how they related. So it makes it a lot easier if you have a standard prefix for each of the areas that does its own debugging. You can see what the prefix was. Does this make sense what it does to people? I'm getting mostly nods. Okay. So there's new storage allocated for prefix. Each time you pass through this sub, a new lexical variable $prefix is snagged off the stack, and it's kept alive inside this subroutine. So this prefix right here is unique to every pass through gen debug. That's why you can see this sub is a closure, because this prefix is only alive as a value inside of this subroutine. The ability to do this with subroutines is a core part of Lisp and their whole notion of first-class subroutines and whatnot, is the fact that I can create an anonymous subroutine and encapsulate its behavior. Now, one thing, great utility if you use a lot of closures or a lot of anonymous subroutines in general, is subname. And it attaches to the subroutine a proper name. So if I have subname debug, for example, and I have this subroutine, the difference is this is what you get if there's a problem, if you have a die or a warning. This is the sort of output that you get from an anonymous subroutine. And it's really obvious what that means, right? Everyone here can see exactly what that is. This is what the output looks like if I use subname on that anonymous subroutine. I can give it a real name. So when it pukes or gives me a warning or gives me the output of a try block or something like that, I get a real name that's readable. And it's a good way, again, it just makes your, especially when you're troubleshooting something at 3 in the morning, it's a hell of a lot more readable if you've got the subname on it. This stuff will be on speaker deck when I'm done with it. So if anyone actually cares what I'm saying, you can look it up there. So if you wanted to have a handler generator, you could have, and it does, let's say, debugging. I can have this gen debug, and for each of these things, I give it a name, I give it a prefix, I give the subroutine a name, and I pass it back. And the name, if, again, using signatures, I could default that to, debug, and I could default the prefix to hello world or something. But this makes it really easy to come up with little debug output generators from different points in the code that each have their own prefix and each have a reasonable name. Does this make sense? Okay. People nodded, so you're at least awake or falling asleep. I don't know which. So another great thing about Perl that makes these really useful, you can dispatch into a subroutine in Perl using a variable. So I can call object, it doesn't even need to be a regular object, this can be a string. But if I have an object $method, that is perfectly valid C, which means I can create dynamic code. So if I have a frobnicate, I can call sub foo of frobnicate. That method will get pushed in. The method will get looked up on the stack, and I will call it using a standard method dispatch by name. One cute trick is I can bypass all of that lookup. So if I'm trying to get down to some derived class further down the stack, I can pass a reference to it in, and object points to method is going to go straight into that reference. That gets really cute because I can create a closure. So I can create a one-time method. I can pass that in, and I can dispatch using an object into that method. That closure can encapsulate all kinds of fun things. The object has no idea what it's dispatching into. It just goes there. And by the way, this is a good example of a way to use that debug, because I can call $object points to $debug with a bunch of stuff. And now I've got my prefix, and I can have timestamps. That closure can put a timestamp, all kinds of fun stuff in front of each log message, and the object doesn't need to keep track of it. If you really want to have fun, you can assign a glob an anonymous subroutine, which then gives me a named method that I can install at runtime. This is what a lot of exporter stuff does. Where it gets really cute is I can localize it. We've all been in a situation where you're calling some standard thing and it just blows up because it wasn't designed to handle one situation you're in. As a crutch until you can fix it, you can actually localize a subroutine that deals with the situation and dispatch it by name. And in that context, you've overridden the named subroutine because the local sets up a local value for a global symbol. So you can actually hack the symbol table on the fly, which is fun to troubleshoot, but it does give you in Perl a way, especially if you're transitioning between systems or you were just told, gee, we've got this new library that works perfectly, it never fails. You know, and of course, there's one place that it does. You can wrap extra boilerplate on it. So the reasons for using these closures, the first is encapsulation. If I dispatch into a closure, I don't have to know what it does. I can't look inside the subroutine once I've engaged. It's just a sub, it's a subref. Whatever that thing does, it's going to do, and I don't have to worry about it. So again, this is a nice way, and you can take arguments. So I can have an object, and I can dispatch into a private subroutine that does whatever it does. I can configure that at runtime, or based on a configuration file. So it's a good way to have dynamic methods. Another thing is delayed dispatch, if anyone's seen my stuff before on Object Trampoline. I can bless a subroutine into Object Trampoline bounce. What this will do is replace the trampoline object with the thing that you would have want constructed only when you call a method on it. Because Object Trampoline bounce has no methods except for the autoload. Anything you call on that trampoline is going to start by replacing the first item on the stack with the result of executing your constructor, which replaces the calling context's view of the object. Because remember, it's passed by reference on the stack. The cute thing about this, and why this works so well, is there's another method, another package in that same module called Object Trampoline Use. And it takes the extra step of using the package. And this is for, let's say you've got a system that has to do language management, and it's got 14 dictionaries. And you don't want to load all of every dictionary every time you ever start anything. This allows you to amortize that over the time it takes to call each of them. So you might delay loading some things. At that point, notice something. Object Trampoline bounce at the bottom doesn't change. The closure encapsulates everything that happens, the extra use statement, and then call the constructor. Well, at that point, I don't have to modify Object Trampoline bounce to have different things utilize it. I can have another one that does a require, another one that does a use, and some setup. I can do all kinds of custom things and bless them into bounce. Bounce has no idea what's going on. Another use for these is what's usually called inversion of control, if you like long words. And the point here is I can have some boilerplate code which prints lines. And maybe some of the time I don't want to print comments, some of the times I don't want to print blanks, some of the times I want to make it all uppercase, who cares? But the basic process of read something printed doesn't change. And all the error handling of open the output file, does it blow up, that doesn't change. So instead of trying to put all of the logic for all the different things I would do in a huge switch in print lines, I can start here and say, well, give me something that extracts what has to be printed from a read line. So if I set readline, if I go in the bottom here, I call extract readline of input. This print lines has no idea what is going on inside of that extract. All it knows is it gets lines back. This is less a use of closures than just first-class functions where I can pass a reference in. But now the print lines it calls the extractor and gets what it needs. And then it prints everything out with line numbers on it and whatever else formatted. This is a great way to handle things like log files or code reviews. You might want to do, if you're doing troubleshooting, you might want to strip a certain amount of garbage out, strip out the stuff that's info. So you might have one of these called no info or no debug or whatever. Now, the great thing is no blanks and no comments could be closures. They could have a separator. And the only thing I put into those is a my dollar separator equals, and then generate a subroutine that splits on dollar separator and then cleans it up and then passes it back. So you can stack these. You can have one thing, you can actually nest closures, which gets into some fun stuff. But the point here is that print lines can use this extract without having to know anything about what it does. It just gets the results back and processes them, which makes a really nice division of labor, because you can have a standard way of doing something and then vary it. So the example I'm going to go through today, people here played with L values in Perl recently. The newer system is really nice for that. And I'm going to use L values and then show you a way to add boilerplate to them with Sentinel, and then show how to do the same thing in Raku. So the example in Raku uses signatures, uses isRW, and there's some changes in what you can do. So an L value basically is something that can, and anyone here read K&R? You have to, come on, you gotta raise your hand on that one. You just told us about it in your talk. Anyway, an L value is anything that can appear on the left side of an equal sign. That's it. So in the first line and the second line, the third line is where people go cross-eyed. A and B are L values. That A equals B equals C is perfectly valid C. It's perfectly valid Perl. You assign a value, you keep going, you keep going. And at that point, A and B are both L values. At A equal to something, %A, they're all L values. I can assign to them. The cute thing is I can have a subroutine or a keyword or a built-in method, that can take an argument. So subster, anyone ever assigned to a subster? Okay, so you've seen that one. So I can have some definition of Christmas and change that to over the rainbow by assigning the string. So basically what that's showing me is that the subster is an L value. It identifies a place in the string that I can assign to. Is this making sense? Mostly nodding? Okay. So I can write my own. I can have a sub foo, and if I stick that magic L value after it, this is the simplest kind, and it's a closure. The simplest L value handler is just a state variable. What this is going to do, the first time I enter here that state variable, Perl's going to say, wait, I haven't seen that before. It's going to stuff 1 into $I. And after that, it's going to return $I. And it's going to return $I forever. The fact that it's an L value means that it's the return is actually the variable in an assignable state. If you read from it, you're going to get the contents of the variable. If you assign to it, you're going to stuff it into the variable. Does this syntax make sense to most people? Everyone's nodding. Okay. So if I say A equal foo, I'm going to get 1. I can assign 10 to it. I know I'm going to get 10. And this looks a little, by itself, it's kind of like, why would you bother with this? But now, again, going back to the example of a global variable. What if I wanted to have something that picked up a global variable and then didn't get affected by it if some other point in the code changed the global? Or I wanted to assign a default to that global. This is the simplest way to have a verbose setting in a piece of Perl code. I snag it out of env of verbose or whatever, and now I can call verbose. If I say if an object points to verbose, then I'm going to get the current verbosity regardless of whether that global has changed. If I assign to it, I'm not going to step on someone else's view of that global. So it's a good way to make sure that you've encapsulated that and put it in a safe place. So an example of using all these things would be if you want to templatize a class in Perl. What you want to have is a list of attributes. I want to be able to install them on the fly from a config file, from reading a database, from whatever. Maybe I want to have a method for each column in a database. And I want to have it so that anytime I call that, I can read it. Anytime I assign it, I can assign it. But I want it to be dynamic. So when I create the class the first time, I get all the methods I need. And a way to do that is I can have one sub here that takes a package and a list of names and then installs a subroutine that's just a state value. That gives me, for each attribute name that I wanted, I've got one private value that's local to that accessor. You can't get to it outside the accessor, in fact. So this sub al value, we've seen that state value. Every time I read it, I'm going to get it. Every time I write it, I'm going to save it. And the only place that it exists is in here. One cute thing, qualify to ref is an amazing, the symbol module makes all the stuff that people do with turning off strict and playing games with the symbol table. Please stop banging your head against the brick wall. Qualify to ref gives you a ref to a thing. So if I do $ref equal subname names that it has a real name if it pukes, it's an L value with a state. That's it. I've just installed a method into a package that returns or has an assignable value in it. I'm done. That's all it takes. This is pretty much the same mechanism that exporter uses when you export subs. It's just instead of the sub being a local closure, it's a reference to something in your code. Does this make sense the way I'm showing it? So, again, in the second red line here, I can say if the ref to code, this is the thingy notation that says, okay, if there already is an accessor for this, skip the next step. So this ref says, find me a thing inside that package, dereferences it as a glob. A glob to code says, give me a reference to whatever code has that name. Well, if it's there, skip this, otherwise assign it. Important, that value only exists in here. So the classic problem you have with a lot of people who use Perl classes that are based on a blessed hash is you can go into the hash keys and you can tickle the thing bypassing its accessors. This is a quick and trivial way to convert yourself from using that bad habit, and there's no backdoor. There is no, the only place these values exist in the code is within the accessor. So you can't backdoor the method. Does that make sense to people? So this gives you perfect encapsulation of the values. And if I wanted to, I could also have initializers. If I passed in a list of key value pairs, I could initialize the value. And again, this my$val is alive only inside of the sub. Once I've gone through this loop, each of those values is now private. There is no way in here except for the class accessor. Now, everything I've shown you here, and probably gone through a couple of people's heads, there's no sanity checks on the assignments. I mean, if I've got a counter, I could assign my mother the car to it and get 0 by mistake. So it would be nice if we had a way of doing something to just boilerplate these. And yeah, you'll never guess what the fix is. more anonymous subs. There is a module called Sentinel. Has anyone ever used that? Okay, there's one other weird person here. The trick is, I can have a class with a method, declare the method as an L value, and I give it a pair of subs, one for get and one for set. And this is from Paul's documentation. It basically says that I've got this class if the method foo is an L value, it's assignable. But if you want to get anything, I'm going to call this. And if you want to set anything, I'm going to call something else. Does that make sense? He does the work of figuring out whether or not you're being called in a getter or setter context based on the call stack, and then dispatches into whichever of the right sub you need to use. You can see this on, if you look up Sentinel and Meta CPAN, and that's the important thing is all the work of deciding whether this is setting or getting or stacked or whatever. You can call this with a stack a mile long. If there's no equal sign on the left side, you're just going to do a get. So he takes care of all that, and it's not something that's easy to do without a bit of SV magic. So now I can say, well, what if I wanted all of my getters can just grab the value? Let's say I'm not encoding the value. I just grab it. But for anything that I'm going to set, I want to pass it through a sanity check before I allow you to sign it. This will do it generically. It's that same install attribute we saw before, but if I give it initial value and a sanity check, the sanity check is the thing that will return it. So the value is object to sanity check of whatever's on the stack. Now that means I can pass, normally @ underscore is going to be one value. You could use $_ of 0, but does this make sense? I'm keeping asking this because some of this stuff gets a bit obscure. So now I could have validate foobar. I can pass that in as a method name, and anyone trying to assign to using this foo is going to call my method. I could pass it an address of a subroutine. And that saves me from the stack lookup. It means I know exactly where I'm going to go in the stack. This is nice if you've got something that's inheriting, that's other classes are derived from it, and you know where in the stack you want to do the validation. You don't want to allow overriding your method. And of course, you could have an anonymous subroutine. You could have a closure that does this. So you could actually install a module whose sanity check was based on a configuration, which gives you a completely dynamic class. Because I can instantiate a class, all of whose methods are built at runtime, all of whose sanity checks are based on some configuration for what that particular class is dealing with at the moment, and it'll just run, and it's very fast. So for example, I could have, if I do a read configuration of my field names, and this might go into a database, it might go into a YAML file, whatever, I've got a value, and let's say I've got an upper and lower, and I've got something whose its entire purpose is just validating ranges of things. These might be dates, these might be numbers, whatever they are. Now what I say is, if you want to assign anything new, I'm going to start by asking, is the new value greater than or equal to my lower or less than my upper? Otherwise, I'm going to croak. Otherwise, I return the new value. Again, this can come out of database, config file, whatever you like, but I now have a class that I can dynamically instantiate its limits. I can have one of these that does, numeric comparison. I can have another one that does LTs and GEs, so it does string compares. So everything I need can be dynamically built, which makes it a lot easier than going into code and changing it. This is really neat for situations in ETL where, for example, every day you're going to run this thing and you want it to reject data that wasn't for today. And you've got suppliers who are sloppy, and occasionally they have bad inputs where I've gotten this. We got stock quotes for tomorrow. My crystal ball isn't that good, and I don't trust anyone else's. I only want stock quotes from today or from yesterday. And you do it yesterday, and maybe you get delayed running by 3 minutes, and you get late enough in the day that their stock quoting system is starting to report today's numbers. You don't want those yet. So you could have this upper and lower be Unix times for the beginning and ending of yesterday. But now the ETL code doesn't have to know that. It just knows that it's comparing things. Your sanity check does the work. And the general ETL that says read me a line, grab the fields, take the sanities, you'll only assign things that are meaningful. Does that make sense? A couple of nods. Anyway, another thing, again, I pointed this out before, if I look at these two values, that value at the subinstall, each time I call this function, the subroutine, I'm going to get a new $val on the stack. That's kept alive in these two different subroutines. They're both closing over $val. They've got the same $val. I mean, whatever I return, whatever I write is the same variable. But it's private to those two subroutines. There is no way to bypass the accessor in the class or outside of it. There isn't. So it's a much better way to encapsulate data. Now, I was looking at this to benchmark it. How well does this work? So if I might have something that I do assign a bare state, and if I just say the state eval equals or my new equals shift, those are the two basic operators that I'd be testing if I do my value is this and assign the value. So a good way to write these would be to say, I'm going to shift something off into a new value. If the new value is, I'm not going to have much time for questions. If the new value is garbage, die. That's important because it leaves the current value untouched if you hand something bogus into it. If you make a bad assignment and you trap it, your next call is going to get the good value that was in there before. So it saves you from stepping on your own feet, getting halfway through a 10-hour run, and you find, oh yeah, we put the wrong variable in there, but we just didn't notice it. This is another cute thing. If you have a subroutine with a bunch of underscores, it makes it easy to see where the dividing lines are between. So I can do a benchmark like this. I'll go pretty quickly through this. I had to use 2 to the 28 on my notebook to get a meaningful timing for these. It gives you some idea how fast it is. And I did time doing just a read, and reading with a sentinel, and writing with a sentinel. And it looks like this. Isn't that pretty? The cute thing is, it works. I can check before and after and find the values got updated. One thing you do in benchmarks, this is another talk I've done, is to avoid lies, damn lies, and benchmarks. Benchmark the basic operations you're performing before you run the benchmark, because you don't know how much of it was overhead that had nothing to do with what you're testing. So in this case, we can see that just calling a sub 2 to the 28 times generates no overhead, which tells me that calling subroutines in Perl is so damn fast you don't care about it. Premature optimization. The other thing is, if I do 2 to the 28 of these, I eat about 5 seconds doing assignments, and I generate a couple of seconds of time generating random numbers that I use. So I've got to take those out of my run times when I look at what I'm actually benchmarking. If you do the corrections, it takes 10 wall seconds. So I can get about roughly 90 megahertz on a notebook doing reads out of closures, which is fast enough for most purposes. And again, that's on a notebook. On writing, I get around 26 megahertz. So if you had the Kafka queue from hell and you were trying to chew through it, you could assign data and pass it out at around 26 million records per second. At that point, the overhead of assigning these things to create the object before passing it on wouldn't be much. Sentinel's a lot slower, an order of magnitude, but it can still handle 1 million records a second, which for web service, for most of the things you do on the top half of your code, where you're taking data from the outside world and validating it, that's as fast as I can pump data over a wire or off of a disk drive. So Perl code that's using Sentinel is probably fast enough for almost any ETL you're going to do. And that allows you to put perfectly good boilerplate, and then the L-valued methods give you a really nice, clean, simple interface. You don't have to worry about set underscore, get underscore, which is what. You just have the name, and you either assign to it or read it. So Sentinel's slower. If you use the bare L values, in the bottom half of your code, in the safe parts, you can go fast enough that you don't care. Raku has, of course, a slightly different way of doing it. The thing here is if I have a Twidgel bang, which is a private attribute, I can give it a read-write accessor, and that's an L value. The way the classes work in Raku and the new Perl system, which I'll describe tomorrow, each object is a closure. It closes over its field values. So this isRW says I've got a local $bar associated with each of my objects that has a bar, has this anonymous accessor. So if I assign to it, if I read it, it works. I can use a public attribute, declare it $.bar isRW. I get an L value also. So this is the same basic thing we saw with the L value in Perl. There's a proxy module which does the same thing as Sentinel. You can do a fetch or a store, and the syntax is about like this, which doesn't actually match the documentation, but we tested it. And by saying it's read-writable, you can fetch it, you can store it, and the subs close over this $bar effectively. They close over the field, so you get one closure per object. Now, I can have something like this. I can say my store only takes positive values. So if I've got, let's say I've got data coming in from sensors, and some of the sensors, because of thermal drift or other problems, return out of range data, I can say anything less than 0 from this sensor is 0, because I know anything less than 0 was just, it was garbage. It was just, a bad voltage. I can do that now. So I can assign -1 to something and read 0 out of it. So this gives you a really, really simple, powerful technique for generating objects that have clean values without going through a lot of code every time, because that store is built into the access for the L value. So you don't have to call set this, get this. You just assign to it, and you know that everything else is taken under the hood, which does a much better job of encapsulating the object for your outside users. You can use multi-methods. So a signature in Raku is an object that comes after the name and before the body. So I can have a method int. What that's going to say is anything I pass into this new is going to be cast as an integer. So even if I pass 1.23, I'm going to get a 1. Another thing I can say here, if I have, here I have this $prior, I create $prior, now my reset method says take the value I was given and set the current value to it, and call that. Well, now anyone that wants to reset the counter to its initial value doesn't have to know its initial value. That's built into the reset for this object. Each object has its own reset. Another thing you notice, if I have a counter, I can have a next and an increment. If I call it next with nothing, I'm going to go into ++, because that's faster. Because adding 1 is just built in. If I want to have a numeric increment, the int will cast it to an integer, so it's appropriate for doing increments with. And then I'm going to do a +=, which is slower. So the signatures in Raku give you a bit more control over how you do some of these things. And that was it. The real thing is L values in Perl or the isRW and Rakus give you a really nice way to have methods that can encapsulate their sanity checks and help standardize your interfaces. The Sentinel and the proxy take care of that. Multi-methods add a bit of flexibility in Raku because you can dispatch to different methods depending on what you're passed. So you can have different sanity checks based on what you're doing. Bedside reading, in Perl sub, the signatures. There's a bunch of them, but L values one. There's Sentinel. Prototypes in general, there's a good Perl monks that I had there that describes the constructors. Oops. And benchmarking in Raku, and that's the stuff I've done for the last few years is all on, and this will be on Speaker Deck under me. So if you care about all the other exciting things we've done with closures, you can go back and look at those. And that was it. Is anyone still awake? You have a question?
Point, actually, Perl 542 is allowing, or is adding the ability to use my method.
Yes. And that's show up. Well, there's only one track, so that's easy. Show up tomorrow, and I'll be describing that, actually, how to use those in your objects. And I've been told to get the hell off the stage. So. Oh, yeah, he was pointing out that 542 now introduces my sub and my method. My sub is already out there. My space method, which is pulled in from Object Pad, allows you to have a private method that extracts its own dollar self and does the rest of it. So that allows you to install these things and have them be private to the class. Yeah, you had a question or a comment or anyone?
Oh, actually, could you just go to that last slide?
This will all be online. Well, he was just want to see the last slide. Yeah, if you want to see my stuff, you can look me up on Speaker Deck. There's a bunch of bad stuff on Perl there. Yes. Anybody else or? Yeah, no, I was.
Okay, thanks. I just wanted to point out that you need to certainly set up your sanity checks in your subroutine. Let's say you really do need to override that, and because this is Perl, you can take a reference to your L value and use that later to assign. Let's say you only want positive numbers, but for this case, I have to make it negative. But if you grab the L value reference, you can still stuff anything you want into the private accessor.
Yeah, you could take a reference to it.
To do that, but
You can backdoor it, but I don't even know if that works in every case.
where you need to localize a method because reasons.
But yeah, if you needed to backdoor it that way, because it's an L value, the easiest way to do that would be you can take the anonymous subroutine that you install as the watcher and just add whatever logic you would have done that tried to use the reference to an L value in order to backdoor the sanity check. You could just take that same logic and stuff it into the sanity check because you can make those dynamic.
Yeah, and you brought up the assigning to substring. You can do that trick also with substring and take a reference to a segment of a string and assign to it later.
Yeah.
Yeah, I think L values are great.
You can do some really cute things with them.
Being able to assign inside of a string, substring is pretty awesome. Thanks.
Anything else? Oh.
The syntax that you showed in Raku that you said would convert, I'm not sure the exact word you used, that to
Well, it's going to cast it to an int.
right, but that will, if you pass that anything other than an int, the code that you showed,
Oh, it's going to puke.
it will refuse, yes.
Oh, okay.
There's a coercion syntax that you can use where you would say int parenthesis any parenthesis, and that will take anything and coerce that
Oh,
Everything you said, it just doesn't.
catch me after and I'll update the syntax.
And also, I heard you say that docs didn't match something. Catch me after we'll get docs updated.
Yeah, there was a gotcha in the. Yeah, I've been told last question if anyone has one. Anyone who's awake, you get the last question.
Actually, this is a random, probably newbie question.
No, that's fine. That's what you're here. That's what we're all here for is getting people answers.
Towards the beginning of your talk, you were showing a Perl code where you use a state variable to store the format string. Why is that?
Well, let's say I use this is the first state place. A state variable like C is where it's. So why would I use a state variable? The point here is that the first time you enter a subroutine, any state variable that has not been assigned already gets its default. And then as you exit, the value in the state variable is preserved. So the next time you enter the subroutine, the old value of the state is still there. So it maintains its state across multiple passes through the subroutine.
Okay, but like if you go like the next slide, I think it is, maybe the next one. Sorry. One with the format screen.
Yeah, I'm trying to find it.
Because it doesn't look like. There we go. That's the one I was thinking of.
So I have.
So creating that format string, is there any extra overhead going on where?
No.
Even setting.
No, what happens is state $FMT. He was looking at. I don't think I can highlight on this thing here. No, it's right here. It's state $FMT equals. All that does is create for me a private variable $FMT. That the first time I enter the subroutine print lines, it's going to get assigned that value as a default. And each time I re-enter the subroutine, that value that it had the last time I exited the subroutine is still sitting there. So each time I only perform this assignment once. I could have said my $format equals, and it would have reassigned the same value to a new lexical variable every pass. This says the first time assign this and leave it there alive. The next time I enter the subroutine, it ignores the equal sign because it says, I've already assigned this once. Don't take the default, just keep going.
Okay, so if that was just like a regular line, what would end up happening is if you called it 10 times, you'd have 10 different.
I'd reassign that same fixed string to it 10 different times. And it would cause probably, yeah, it might cause, a few dozen nanoseconds of extra overhead. I just, using a state variable there was just reflex. It makes more of a difference if you've got something like, again, if you've got an L value, back to something that gets assigned, oh, come on, damn it. There we go. In debug, you're going to pass through this, you're going to hit the debug sug the first time. Perl's got a flag on the variable that says, I'm bare, I've never been assigned before. But I'm a state variable, so I keep alive. It's going to hit the equal sign and say, you have a default. It's going to look in an env, it's going to do the OR, it's going to shove a value into that state. It's going to exit the subroutine and keep the variable alive. The variable basically has an extra reference count that when I exit the scope of the variable, the space doesn't get reallocated. So now I come back in the second time, and the third and whatever, and it says, oh, I've got the little flag on this variable that the SV has been set once before. I don't need to go through the work of the equal sign again. And it passes through there. The value is still there, but it doesn't need to be reassigned the state. The point there is debug, if I've got using this for an L value, if I assign to it, that new value gets stuffed into the state variable, and the next time I pass through the subroutine, the state variable doesn't overwrite the old value with the default. because I already assigned it once. It doesn't get reassigned the second time. It just sits there.
You're saving like 3 ops there.
Hmm?
You're saving like 3 Perl ops there.
Well, more than that, actually what I'm really saving more than anything is a set of curly braces and a do block and having a variable that's outside a subroutine that some nerf brick says, why do I have that stupid subroutine variable there? I'm not using it for anything, and they take it out and my code fails. So the state variable is nice for this kind of thing because it puts stable values inside the subroutine where they're both private, and they're right in the subroutine where you don't accidentally delete them because you think they don't mean anything. Yeah.
Can you talk about your example of recursion? You were saying
That's dealing with he was asking about an example I was talking about before with him with recursion. That was the issue of dealing with tail recursion in Perl, which is a completely different topic. And there's a good talk on that I did with Damien a number of years ago. I'll find you the reference to the slide, the picture of it. But did that answer your question about state variables?
Yeah.
Probably more than you wanted to know, but that's.
Oh, thank you. Appreciate it.
State variables in Perl are a really neat thing because they save you from having all these dumbass do blocks that only are there to preserve a variable as a my and then keep it alive in a sub. You get the same closure by having a state variable. And then you don't accidentally delete things. It just simplifies the maintenance going forward. Yeah, you had a question?
Point out it's a great way to self-document code.
It helps self-document the code.
State variable, you automatically know this should not change.
Well, and the other thing that's nice about it is it keeps the initialization value inside the subroutine where it's used. So if you pass it the first time and you ask, why did it get that stupid default? You're not stuck finding in the code where it might have set that. You know that it was set right there on the line that says state $variable. It's very declarative that way.
thank you.
That's it. And